All right, let's jump right into this explainer. If you write code in Java, you use objects literally all the time. But the exact mechanism that boots those objects up and gets them ready for action, well, it's sometimes a bit misunderstood. So today, we're focusing entirely on that spark of life, the Java constructor.
So here's our roadmap for today. We're going to meet the Java constructor, compare it to regular methods, check out default versus parameterized constructors, dive into constructor overloading, and wrap up by mastering the this keyword. Let's get to it.
All right, part one. Let's meet the Java constructor and see what actually powers an object. So here's the absolute crucial point. A constructor is basically your initialization sequence. It's technically a special member method, sure, but its one and only job is to give an object its very first legal values the second it's born. When you drop that new keyword in Java, boom, memory is dynamically allocated and the constructor is instantly and automatically invoked to set the baseline for your brand new object.
I really want to hammer home these golden rules, especially the first two. First, a constructor must have the exact same name as the class it belongs to. I mean, perfect matching, case and all. Second, and this is a big one, it will never ever have a return type, not even void. If you see void sitting in front of it, scratch that. It's not a constructor, it's just a regular method wearing a disguise. And remember, you aren't calling it like a normal method. Java handles the whole shebang automatically the moment the object is created.
Looking at this setup, notice how public book perfectly mirrors the class name book. Inside those curly braces, it immediately sets up the starting stats, setting the book number to 0, the name to ABC, and the price to 0.0. This guarantees that every single new book object starts its life with clean, totally predictable data.
Moving on to part two, constructors versus regular methods, and how to spot the difference.
Now, if you're used to regular Java methods, you might be scratching your head wondering how constructors are actually different because they look super similar at first glance. While both can take parameters and use access specifiers like public, their core jobs are totally different. A constructor strictly initializes data exactly once upon creation. That's it, one and done. A member method, on the other hand, you can call that repeatedly to perform actions whenever you want.
Okay, part three, default and parameterized constructors, because there's definitely more than one way to initialize an object. You basically have two paths you can take here. You can either let the object generate with a blank slate using a default constructor. This takes 0 parameters and just slaps in standard default values, zeros for integers, nulls for strings. Actually, fun fact, if you don't write any constructor at all, the Java compiler will just quietly slip a default one in there for you. The other path? You take total control. You use a parameterized constructor to pass specific data right at the exact moment the object is created, and that can accept as many arguments as you need. You can clearly see the difference in action here. On one side, the programmer is explicitly passing the value 190 directly into the parameterized constructor. Because of that, the object initializes with that specific book number right out of the gates. If they hadn't done that and just went with a default constructor, the compiler would have literally just assigned a default 0. It really just comes down to whether you want generic data or specific data at the moment of birth. Which brings us to a really powerful tool in our toolkit. Part 4, Constructor Overloading Explained.
So imagine you're designing a system. Most of the time, you want to build an object with a default state. But occasionally, you need a partially customized state, or even a fully customized state. Are you stuck picking just one type of constructor per class? What if one single constructor just isn't enough? Well, absolutely not. Java handles this beautifully through something called constructor overloading. This simply means multiple constructors can peacefully coexist within the exact same class. There's just one rule. Their parameter lists, also known as their signatures, have to be unique. So you can have one constructor that takes 0 arguments, another that takes an integer, and a third that takes an integer and a float. No problem. Check out this room class to see the magic happen. Up top, we have an empty public room constructor that just defaults the length, width, and height to 0.0. But right below it, seamlessly hanging out in the same class, is another public room constructor ready to accept specific double measurements. When you create a new room object, the Java compiler looks at the arguments you provide and just automatically routes you to the correct constructor. It is incredibly efficient. Now, as our constructors get more complex, we run into a little naming problem. Let's tackle part 5, mastering the this keyword. So here's the issue. We programmers love clear names, right?
If your class has an instance variable called price, and your constructor takes a parameter representing the price, well, you naturally want to name that parameter price too. But if you type price equals price, Java's going to get totally confused. How on earth does the compiler know which one is the local parameter and which one is the actual instance variable?
Enter the this keyword. It is such an elegant solution. It acts as a direct reference to the object that is currently calling it. By typing this.bookno equals bookno, you're explicitly telling Java, hey, take the value of the local parameter bookno on the right and assign it to this object's instance variable bookno on the left. It completely wipes out the ambiguity and keeps your code beautifully readable.
But wait, this has a second kind of mind-blowing trick up its sleeve. You could actually use this with parentheses as a method call to chain constructors together. If you have multiple overloaded constructors, you can use this dot to invoke one constructor from inside another. The control just hands off smoothly from one to the next until the object is fully built. It's an absolute lifesaver for preventing duplicate code across your class. Just remember that this dot call absolutely must be the very first statement in your constructor. Well, we've thoroughly explored how objects are born today, from simple default values to complex, chained constructors pointing at instance variables. But that leaves us with a pretty fascinating question to wrap up on. If the new keyword and the constructor dynamically allocate memory to build an object, what ultimately destroys it? What cleans up the mess? That right there opens the door to Java's automatic garbage collection, which is a fantastic topic for you to ponder for next time. Thanks for hanging out with me for this explainer.